We are going to start today talking about our exponential functions, and as we've talked about already, an exponential function is a function with the general form y equals a times b to the x, where a is not equal to 0, b is greater than 0, and not equal to 1. We'll talk about why all this stuff is important later, but right now the thing you need to focus on is that the variable, the independent variable, is in the exponent position. So the variable being an exponent is what makes it exponential. Now let's talk about each of the parts of these and what it is that we're looking at as we are writing any of our equations. So the a is our initial value. It's where x equals 0. The b is our base, also called our common ratio. Now the base determines whether it is growth or decay. And we're going to go ahead and write this, but we're going to talk more about it later. So if b is greater than 1, then it is growth. If b is less than 1, it is decay. Again, we'll revisit this growth and decay as we look at more examples. And then x, of course, is our independent variable. So we are going to look at an example. And the example that we are looking at is f of x equals 2 to the x. So we are going to do this by taking our equation and creating a table of values. And I am actually going to start at 0 and do my positives first. So again, we are looking at f of x equals 2 to the x. And I'm going to start down here at f of 0. So I'm going to take out the x and I'm going to plug in 0. Anything to the 0 power is 1. So this would be the point 0, 1. f of 1, I'm going to take out the x, plug in 1. So 2 to the 1 is 2. This would be the point 1, 2. f of 2 is 2 squared, which is 4. So 2, 4. f of 3 is 2 cubed. 2 times 2 is 4, times 2 is 8. So this would be the point 3, 8. And then f of 4 would be 2 to the 4th, which is 2 times 2 times 2 times 2, which is going to be 16. So 4, 16. You'll notice that one actually won't even fit on the graph I gave you. Now I did all that kind of fast because our positive exponents are pretty easy to do. We're pretty good at doing 2 and then 2 squared, 2 cubed, 2 to the 4th. The negative exponents we might need a little bit more help with. So I'm going to come back. I'm going to plug in -1. So that's 2 to the -1. Remember, a negative exponent moves you. So if it's in the numerator, it drops you to the denominator. Your exponent becomes positive. So that's just 1/2. So that's the point -1, 1/2. f of -2. I'm going to do 2 to the -2. Negative exponent drops you to the numerator. So that's 2 squared, which is 1/4. So that's the point -2, 1/4. f of -3 is going to be 2 to the -3, which is 1/2 cubed, which is 1/8. So that's -3, 1/8. So we're getting smaller and smaller. And then f of -4 is 2 to the -4, which is 1/2 to the 4, which is 1/16. So that's the point -4, 1/16. Now, I want to point out a few things before we start graphing. So the first thing I want you to notice as I go down the table here, starting here because it's easiest to see, notice that I'm multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I'm multiplying by 2 each time. So if I'm going backwards, I'm dividing by 2. 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. And I can actually keep going. Divided by 2 is 1/2. Divided by 2 is 1/4. Divided by 2 is 1/8. Divided by 2 is 1/16. The other thing I want you to notice, when we are looking at comparing our positive x values and our negative x values, look at 1. The y value is 2. Look at -1. The y value is 1/2. Look at 2. The y value is 4. Look at -2. The y value is 1/4. 8, 1/8. 16, 1/16. That's not by coincidence. That is the way the negative exponents are working. Now we're going to plot our points, and I'm going to start with my positive just because I think that they're a little easier to graph. So I'm going to do 0, 1, 2, 4. Oops, sorry, 1, 2. Almost forgot that one. 2, 4, so 2 to the right and up 4. 3, 8, so 3 to the right, 1, 2, 3, 4, 5, 6, 7, 8. 4, 16 would be off my graph. Now going the other direction, I'm going to have to do a little bit of guessing. So -1, 1/2. So -1 is going to be 1 to the left and then up 1/2, so about right there. And then -2, 1/4, so -2, 1/4, right there. Now, as I go 1/8, 1/16, those are going to be really hard to graph on a graph this size. So I'm going to end it there. I do want you to notice here, as I connect this way, as I connect that way, I'm connecting all my points. And then on this side, they're going to come down, and it's going to ride right above the x-axis. Okay, I zoomed in so we could see it a little bit better. So when we're coming this way, it is going to come down, and it's going to skim right above the x-axis. It doesn't actually touch the x-axis. There's no way to actually make it equal to 0. So there it is. So I'm not going to dip down below the x-axis. I'm going to come right on top of it. So this is our graph for our exponential function y equals 2 to the x, or f of x equals 2 to the x. Again, I want you to notice that as the x values decrease, so as they get smaller and smaller and smaller, the graph of the function approaches but does not cross the x-axis. This is called an asymptote. So this will never actually, it keeps going, it keeps getting closer and closer, 1/16th, 1/32nd, 1/64th. Keeps getting closer and closer, but it never actually touches that x-axis. And the equation for the x-axis is y equals 0. So that's what that is. Now our key features. Our key features to our graph y equals 2 to the x. The a value is 1. Our initial value, if I plug in x equals 0, I get 1. The b value, which is my base, is 2. Our y-intercept, which corresponds to the a, is 0, 1. And we've already said our asymptote is at y equals 0. These two things, the y-intercept and the asymptote, change based on transformations. Now this one, as the graph the values of x are getting bigger and bigger. The graph is going up. So this one is growth. Notice also our base is bigger than 1. Okay? Now, domain and range. Domain is all real numbers because if I look left to right, if I look on the left, I actually do have an arrow there. And if I look on the right, I have an arrow there. So my domain is all real numbers. My range, on the other hand, I come down, but I never cross the x-axis. So all of my y values are bigger than 0. So my range is going to be y is greater than, no or equal to, 0. I can't be equal to 0. I can't be negative. And that is the graph of our first exponential function. We're going to look at more. We're going to look at ones that are decay, and we are going to look at ones that we transform. We move left, right, up, down, same way we did with our parabolas. But this is our basic parent function with a base of 2.